There's a question about how do you tell if a particle is speeding up or slowing down. So this video is an attempt to clarify that, offer a little explanation of how I might answer a question about speeding up or slowing down at a point. So I'm on your worksheet, your practice worksheet with motion problems, number 3, part G is what I'll be working through in this video, or you can just watch it and follow along because I did give you the function that we're working with. So some preliminary work that I did that you probably did at some other point in problem 3 is I took my position function, which was given to me like this, and I just went ahead and expanded that, multiplied it out, so I had a nicer function to work with. Then I found my velocity, you see in blue, and I found my acceleration in green by doing the first and second derivative of that position function, s of t. At this point, I'm ready to attempt to answer the question, and the question is find the acceleration of the particle at t equals 3 seconds. So let's start with that. I've got my acceleration function right here. So acceleration at 3 is simply plug in my 3. 6 times 3 minus 16. So there's my time, going in for my time, and working that out, I get 18 minus 16, which is 2 meters per second squared. So that would have been the first part of the question. But the real question I think that we're confused with is the particle speeding up or slowing down at this point? So we kind of came up with a rule that we can follow, but I hope it makes more sense than just being a rule. The rule was that if the sign of acceleration and velocity are the same, the particle is speeding up. And if they're different, then it's slowing down. So at this point, I need to find my sign. So I know that my acceleration at 3 is 2 meters per second. I just got that. But I'm actually going to write it this way. My acceleration at 3 is, maybe we'll just do a little summary statement here. It equals 2, and that is greater than 0. So here's my key here is I'm comparing to 0. The other way of saying it is just to say that your acceleration is positive at 3. Now I need my velocity, so I'm going to go up to this function, and I'm going to find my velocity at 3, which means that I'm going to try to squeeze it in here, 3 times 3 squared minus 16 times 3 plus 20. And if I do that, it looks like I'm getting 9 times 3 is 27. So I'm getting 27 minus 16 times 3. 48 plus 20. I'm trying to do this in my head. So I've got 47 minus 48. I'm getting a negative 1 meter per second. So I've got negative 1, and that comes out to be less than 0, which is negative. So I've got velocity is negative, acceleration is positive, is my conclusion. And as soon as I figure that out, you don't even actually have to figure out the values. When I was doing velocity, if it was just if this was a really large calculation, but I could easily tell it was positive or negative, the question's not asking you to find the velocity. But that one, it was pretty close, so I had to actually do the math. As soon as I get different signs right here, positive for acceleration, negative for velocity, then I know that the particle is speeding down. So my conclusion is, therefore, particle is slowing down. At time equals 3 seconds, which was the time in question because that's what I plugged in right there. Okay. Interpretation of this, if you're looking for why does this make sense or why should this make sense. If you are in a car and you're going forward, you have, wait, hold on, this is the other one. If you are in a car and you're going backwards, you have negative velocity. But if you push on the brakes, then you're accelerating. So you're in reverse, you're going backwards, negative velocity. You push on the brakes, which means your acceleration is working in the opposite direction. And it's actually pushing you forward or keeping you from going backwards, so you're slowing down. If you have a ball that's thrown up and then is coming back down, we have, no, that doesn't work because that's negative acceleration. So I guess the car example is probably the best example I can give of what that might look like in real life. Hopefully that helps. That's sort of a special case scenario if I'm just doing it at a point. If you're just asked for find intervals when a particle is speeding up or slowing down, then you're going to have to test lots of different areas.